Good morning all of you. Today we are going to talk shortest distance between two lines. So how to find out shortest distance in three-dimensional space? So first one, I would have take two lines in space are intersecting. So I take here two intersecting lines in space. So these are called L1 and L2 are called intersecting lines. The shortest distance will be how much here? Here only, that is their shortest, that is here less, very less distance. This becomes here 0. So remember all of you, shortest distance for intersecting lines. For intersecting lines, so we can take for intersecting lines, shortest distance will be what? 0, remember all of you. So next one, if the lines are parallel in space. So lines are L1 and L2 are parallel, then shortest distance will be perpendicular to line L2. So perpendicular distance. So we know the perpendicular distance formula also. So in this case, shortest distance is equal to, for parallel lines. For parallel lines in space, shortest distance is equal to perpendicular distance. All of you remember this point. Next one, third one, for the lines here, for skew lines. What is meant for skew lines? Skew lines means neither parallel nor perpendicular. That means neither nor. So these are called neither parallel nor intersecting. I will show those values here. For example, see here I take the room like this, cube or cuboid. Any room we can take here. So just we join like this edges, we are getting the room, classroom. So this is x-axis, this is y-axis, and this is z-axis. So O be the origin. So we give the points names A, B, C, O, A, B, C, and next D, E, F, G like this. We are observing here, I draw the GE, this is one diagonally, and also other diagonal I can join like this one. So DB also is a one diagonal. So these two lines are neither intersecting nor parallel also. So here mainly we can see the example also. One of the example here, these two line, GE line, the line GE, so here it goes, observe here, ceiling of the corners only, ceiling of the corners. So like this only, this is the line join, ceiling of the corners. Next, what is the BD line? So BD line, observe that here, so one ceiling and one down corner also. So this is the DB. So this is the above the one, this is the ceiling corner, this is the wall down corner only. So join that. So this line and this line, these are neither intersecting nor parallel. Hence these lines are called skew lines. For skew lines, how to define? For skew lines, how to define the shortest distance? For skew lines, shortest distance is equal to perpendicular to both the lines. So the shortest distance for skew lines will be perpendicular to both the lines. So this is the answer of the question. Now how to derive the equation, how to derive the shortest distance formula, but we don't want derivations. For example, I take the first line, let L1 is equal to equation of a line in the Cartesian form and vector form already we proved. L1 is equal to A1 plus lambda times B1 bar. This is R bar is equal, I am taking R bar is equal to A1 bar plus lambda times B1 bar, line L1, and another line L2, R bar is equal to A2 bar plus mu times B2 bar. So if these two lines are observing, B1 and B2 both are differ only here. So B1 vector and B2 vector, neither parallel nor intersecting meaning. So shortest distance for these lines, formula remember that, magnitude of B1 bar cross B2 bar dot A2 bar minus A1 bar divided by magnitude of B1 bar cross B2 bar. This is the shortest distance for skew lines formula. What is the B1 bar cross B2 bar? So we can find out using vector method. B1 bar cross B2 bar is equal to, so drs of B1, drs of B2. So using this method, determinant method, I, J, K, and A1, B1, C1, A2, B2, C2. This is the method to find out the cross product of two vectors. Next, suppose two lines are parallel given. R bar is equal to A1 bar plus lambda times B bar. L2, R bar is equal to A2 bar plus mu times B bar. We are observing these two lines are parallel. Why? Because here B vector is same. Okay, A1 I do, these are the points, remember, these are the vector, parallel vectors here same, drs of first line equal to drs of second line. So what is the shortest distance for parallel lines? That is equal to magnitude of B bar cross A2 bar minus A1 bar divided by magnitude of B bar. To determine cross product, we have to use determinant matrix, determinant method. So this is about shortest distance between two lines in space. So last class we derived the theorems and formulas also. I repeat once again, equation of a line passing through the point and parallel to vector, that is general form, R bar is equal to A bar plus lambda times B bar. In vector form this is. In Cartesian form, x minus x1 divided by A is equal to y minus y1 by B is equal to z minus z1 divided by C. This is in the Cartesian form. So here in vector form, this is the point, this is the direction, parallel vector. Next here in Cartesian form, standard form, remember, this is minus important, x minus x1, y minus y1, z minus z1. Down here A, B, C are there, drs. Next one, what is the equation of a line passing through 2 points? It is also derived. That is, last class proved that answer. R bar is equal to A bar plus lambda times B bar minus A bar. So this is the equation of a line passing through 2 points here. In Cartesian form, x minus x1 divided by x2 minus x1 is equal to y minus y1 divided by y2 minus y1 is equal to z minus z1 divided by z2 minus z1. So these are the equation of a lines. Next, angle between two lines in vector form and Cartesian form also given. So that is, if two lines are given, what is the angle between two lines in vector form? cos theta is equal to b1 vector into b2 vector divided by magnitude of b1 vector into b2 bar. Next one, in Cartesian form, cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. So here some conditions are there. If two lines are parallel, the condition will be a1 by a2 is equal to y1, b1 by b2 is equal to c1 by c2. Next condition, if two lines are perpendicular, the condition will be a1 a2 plus b1 b2 plus c1 c2 equal to 0. With the help of this we can find the problems. Next here, shortest distance between two lines. For intersecting lines, shortest distance will be 0. For skew lines, this is the formula. If given in Cartesian form also, we convert in the vector form, very easy to solve. So shortest distance equal, all of you remember, magnitude of b1 bar cross b2 bar dot product a2 bar minus a1 bar. Why should we take that bit? To make it scalar, divided by magnitude of b1 bar cross b2 bar, where cross product b1 bar cross b2 bar equal to, using matrix determinant form, I bar j bar k bar a1 b1 c1 a2 b2 c2. We know the method. For parallel lines given, shortest distance equal to b bar cross a2 bar minus a1 bar by magnitude of b bar. Now we are going to solve the exercise problems. So here I have given problems on first theorem, that is equation of a line passing through the point, and parallel to vector in both vector and Cartesian form. So this is very important model problems for 2 marks, 3 marks, 1 mark questions. Okay, from the exercise we have the first model questions, these are only. So how to solve one by one question, observing all of you. The first question, find the vector and Cartesian equation of the line through the point and which is parallel to vector given. So here point given, vector is given. So which formula we have to use? First theorem only, keep in our mind how to take. So to write the answer, so directly let us take, let a bar, solution of the first question this is, let a bar be the position vector. A bar be the position vector, I wrote shortly PV, means position vector. A bar be the position vector of the point A x1 y1 z1, that is equal to what? 5 2 minus 4. Okay na? With respect to origin, then a bar is equal to, in vector form, 5 I cap plus 2 j cap minus 4 k cap. Okay, in vector form, point written. Next here parallel vector is given. So let b bar is equal to, that is given 3i, in vector form already given, 3i plus 2j minus 8k. 3i plus 2j minus 8k. So this means drs of line meaning. What are the drs here? So then drs are 3, 2 minus 8. So these are the drs. General vector, let r bar be the position vector of the point P. Let r bar be the position vector of the point P. Now asking question vector form. We know the vector form. So vector form is equal to formula equation of a line in vector form. Equation of a line is R bar is equal to, all of you remember standard form in vector form, A bar plus lambda times B bar. Substitute, this implies R bar equals, what is the A bar? 5 into I cap plus 2 into J cap minus 4 into K cap plus lambda times B vector is 3 I cap. So 3 I cap, next value plus 2 J cap plus 2 J cap minus 8 K cap. So this is called vector form of a equation of a line in 3D. Passing through the point and parallel to vector. Little, just only substitute in formula enough. No need to derive anything. Solid derived theorem. Cartesian form. So what is the Cartesian form? Equation of a line is, we know that equation of a line is, or equation of line in Cartesian form, x minus x1 divided by a is equal to y minus y1 divided by b equals z minus z1 divided by c. We know all of you. This is the standard form. What is x1, y1, z1? Substitute here, x minus x1 is what? 5 divided by a means dr 3 equals y minus y1 is what? 2 upon b is what? 2 is equal to z minus z1 is what? Minus 4, minus of minus plus 4 divided by minus 8. This is the equation of a line passing through the point and parallel to vector in Cartesian form. So this is the easy method. Firstly take the point in vector form and also take the drs in vector form. Then r bar be the position vector, vector form formula, substitute here. Cartesian form formula, substitute here. Standard form remember. Now we are going to start the second problem. So what is the second problem? Write the Cartesian equation of a line. So asking the Cartesian equation of a line has given. What is asking? Find the vector form. So that means we have to find this is given already in exam. So 2 marks or 1 mark. How to write the in vector form important. So from this we have to find the point only. What is the point here? So convert in the standard form. So x1 is minus 3 or plus 3. So if plus is there, you take opposite sign, minus 3. Minus is there, you take the opposite, plus 5. Here plus there, minus 6. What are the drs? 2, 4, 2. So second question answer, very simple that is. Second problem is, answer of the second question, very simple. Observing. So given line what? Given x plus 3 divided by 2 is equal to y minus 5 divided by 4 is equal to z plus 6 divided by 2. This is the equation of a line in Cartesian form. So from this point here, point A becomes ax1 y1 z1 is equal to minus 3 5 minus 6. Take always opposite symbols. Next here drs of line L. This is the line L we take here. These are the values 2, 4, 2. So these are the DRs of line LR. Next asking vector form. So vector form. So vector form, equation of a line formula, equation of a line is R bar is equal to A bar plus lambda times B bar. Substitute here, R bar is equal to A bar, this is the vector in vector form, minus 3i plus 5j minus 6k plus lambda times B vector in the vector form, parallel vector 2i plus 4j plus 2k. This is the equation of a line in vector form. Cartesian form given, convert into vector form. Vector form given, convert into Cartesian form. Next, third question. So third question also almost all similar. What he has given? Find the equation of a line which passes through the point 1, 2, 3 and parallel to vector given. But in this problem he has not mentioned vector form and Cartesian form. So you can use any formula, either vector form formula or Cartesian formula. So we can write here simply point given, DRs given. So answer of this goes third one. So directly what is the point here? Let A x1, y1, z1 I take directly. In this he has not mentioned in the vector form and Cartesian form. What is the point here? 1, 2, 3 given. What is the parallel vector? B vector. So that means B vector is equal to 3i plus 2j minus 2k. What are the DRs? DRs means I, j, k coefficients. So equation of a line in the Cartesian form I take here. So equation of a line is x minus x1 divided by a is equal to y minus y1 divided by b is equal to z minus z1 divided by c. Now substitute the values x minus 3, x minus 1, x1 is 1 upon 3 equals y minus 2 divided by 2 equals z minus 3 upon minus 2. If you want in vector form, this is the method. Directly do it. Then we are going to fourth question. What is the fourth question? Find the equation of a line in vector and Cartesian form. So this is nothing but first question model. Okay. So similarly we can solve that. Can you solve this one? What is the point here? So point is 2i minus j plus 4k. So what is the a value? What is the x1, y1, z1? Coefficients 2, minus 1, 4 given. And direction meaning what? Parallel vector is given. I plus 2j minus k. What are the DRs of here? 1, 2, minus 1. So using vector form. So here only let a bar be the position vector of the point P. Point here. Point any point A with respect to origin. A bar equal to given. B bar is given. So DRs point take. R bar be the position vector of the point. So do yourself. So this is similar to as it is first question model. Equation of a line in the vector form. Equation of a line in the Cartesian form. Next we are going to the fifth question. I just revised this one. Find the Cartesian equation of a line which passes through the point and parallel to this line. So little changed here. So equation of a line in the Cartesian form. So how many conditions are needed here to find the Cartesian equation of a line? We have two conditions. For the first one is point required. Next necessary condition is DRs. So here already given according to the problem. So given point is let A is equal to Ax1, Y1, Z1 is given. What is the point here? Minus 2, 4, minus 5. Point has given. And what is the line is given? So line L. This is equal to x plus 3 divided by 3 is equal to y minus 4 divided by 5 is equal to z plus 8 divided by 6. What are the DRs here? So DRs are 3, 5, 6. Okay. Parallel means DRs of our required line and given line are parallel. Parallel means DRs are equal. If two lines are parallel, then DRs are equal. So required equation of a line. Required equation of a line in which form? In Cartesian form. In Cartesian form. So we know the answer. X minus x1 divided by A is equal to y minus y1 divided by B is equal to z minus z1 divided by C. Substitute the points. This implies x minus x1. x1 is what? Minus 2 becomes plus 2 divided by A 3 equals y minus y1. That is y1 is what? 4 divided by B 5 given is equal to z minus z1 is what? Minus 5. It becomes plus 5 divided by 6. This is the required equation of a line in Cartesian form. So parallel meaning DRs are equal. If DRs are equal, lines are parallel. Next solution for sixth question. So what is asking here? Cartesian equation of a line given. Write in the vector form. I already this model finished in example second question. So same model is given. So sixth question also. So do yourself. So do it your own. How means here? Let us see. What is the point here? Vector form given, Cartesian form given, Cartesian form given. So find the point. What is the point here? Take opposite always. So here minus 5. We are taking plus 5. Plus 4. Opposite sign. Minus 4. So 5 minus 4, 6. This is the point. And DRs of this line. What are the DRs? ABC values 3, 7, 2. So take here. Let point is taking and DRs of line taking here. Vector equation of a line formula. R bar is equal to A bar plus lambda times B bar. Then substitute that which is the required equation of a line, okay, in Cartesian in vector form. So this is the exercise part. I will continue the exercise part. The next question is seventh question. Okay, today we see this one. Formulas mainly thorough all of you. Formulas here mainly equation of a line in vector and Cartesian form. First theorem. Second one, equation of a line passing through 2 points in both vector and Cartesian form. Next formula, angle between 2 lines in both vector and Cartesian form. Their conditions must be remembered. What are the conditions? The conditions are, remember, for parallel given, how to show that parallel. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. How to show that perpendicular? A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Next formula, shortest distance model. For intersecting lines, shortest distance will be 0. For parallel lines, shortest distance formula, magnitude of B bar cross A2 bar minus A1 bar by magnitude of B bar. For skew lines hangandre neither parallel nor intersecting. So what is the shortest distance? Magnitude of B1 bar cross B2 bar dot A2 bar minus A1 bar divided by magnitude of B1 bar cross B2 bar. So exercise problems. So we have to continue these problems like this. Next, second theorem model problems. Okay. Thank you.